in a time-lapse video, it looks like a monster coming alive. For a moment, it sits there innocuously. Then, ripples blow across its surface. It bulges outward, bursting with weird boils. It triples in volume. Its color darkens ominously, and its surface hardens into an alien topography of peaks and craters. Then the kitchen timer dings. Your cookies is ready. What happened inside the oven? Don't let the apron deceive you. Bakers are mad scientists. When you slide the pan into the oven, you're setting up a series of chemical reactions that transform one substance, dough, into another's, cookies. When the dough reaches 92 degrees Fahrenheit, the butter inside melts, causing the dough to start spreading out. Butter is an emulsion, or a mixture of two substances that don't want to stay together, in this case, water and fat, along with some dairy solids that help hold them together. As the butter melts, the trapped water is released, and as the cookie gets hotter, the water is spent into steam. It pushes against the dough from the inside, trying to escape through the cookie walls like Ridley Scott's chest-bursting alien. Your cookie may have been home to squirming Salmonella bacteria. An estimated 142,000 Americans are infected this way each year, though Salmonella can live for weeks outside a living body and even survive freezing. 136 degrees is too hot for them. When the dough reaches that temperature, they die off. You'll live to test your fate with a bite of raw dough to sneak your next batch. At 144 degrees, changes begin in the proteins, which come mostly from the eggs in your dough. Eggs are composed of dozens of different kinds of proteins, each sensitive to a different temperature. In an egg fresh from the hen, these proteins look like called up ball string. When they're exposed to heat energy, the proteins shrink, unfold, and get tangled up with their neighbors. This linked structure makes the runny egg nearly solid, giving substance to squishy dough. Water boils at 212 degrees. So, like mud baking in the sun, your cookie gets dried out, it stiffens. Cracks spread across the surface, and then steam that was bubbling inside evaporates, leaving behind airy pockets that make the cookie light and flaky. Helping this along is your leavening agent, sodium bicarbonate or baking soda. The sodium bicarbonate reacts with acids in your dough to create carbon dioxide gas, which makes airy pockets in your cookie. Now, it's really ready for a refreshing dunk in a cool glass of milk. One of scientific reaction occurs at 310 degrees. This is the temperature for Maillard reactions. Maillard reactions result when protein sugar breaks down and rearrange themselves, forming ring-like structure, which reflects light in the way that gives sweet like Thanksgiving turkey and hamburgers their distinctive rich brown colors. As the reaction produces a range of flavor and aroma compounds, which also react with each other, forming even more complex taste and smell. Caramelization is the last reaction to take place inside your cookie. Caramelization is what happens when sugar molecules break down at high heat. From the sweet, nutty, and slightly bitter compounds with defined wild caramel. And in fact, if a recipe calls for a 350 degrees oven, it's never happened since the caramelization starts at 356 degrees. If your ideal cookie is barely browned, like a northeasterner on the beach vacation, you can have set your oven at 310 degrees. If your cookie has nice temp, crank up the heat. Caramelization continues up to 390 degrees. And here's another trick: you don't need that kitchen timer. Your nose is a sensitive scientific instrument. When you smell the nutty, toasty aromas of the Maillard reaction and caramelization, your cookies are ready. Grab your glass of milk, Put your feet up and reflect that sign can be pretty sweet.